Good morning, everyone, or good afternoon, or good evening, wherever you are in this part of the world. Uh, this is Ahmed ElZeftawi. Uh, I am talking from Cairo, Egypt, and this course is about well intervention. We have been in two sessions last week. This is the third session, which will be about well completion. Before we talk about it, maybe I will introduce myself quickly to people who first join me in my sessions. My name is Ahmed ElZeftawi. I'm a mechanical engineer, graduated back in 1983. And since that time, I'm in oil field industry. I worked for service companies. I worked in many branches. I worked in wireline, in coil tubing, in well testing, in completion. Um, I work as a site manager, operation manager, director. And part of my work is creating service companies for investors. I did that in many countries in the Middle East, and I am working as an instructor since 1995. I teach this course in almost 18, 19 countries around the world, and this course is a well intervention, but it is, I would say, it's a well intervention for the beginners. Not a condensed course with intervention as it should be for where we teach it to or conduct it to um, engineer who have been years in the oil field industry. I understand that the majority of you are just still studying, but we will talk it in a simple way. In well intervention, again, I always say it is a science of dealing with life wells. Because dealing with life wells, you are dealing with a monster. You are dealing with pressure. Pressure is very hazardous, uh, very strong, very smart. So if you didn't know how to deal with that, you are in deep trouble. So the last two sessions, we talk about how to control the well, how to deal with the pressure, how to deal with the gas, because gas is what creates pressure, actually. Without gas, there is no hydrocarbons at the surface. And in this session and next one, which will last today, will last for 1 hour or so, we will talk about the well completion from the point of view of well intervention. Uh, so the objective, as you see, it is general knowledge. We will not go to into details because if we go to details, we'll talk about completion. We might stay together maybe 3 months talking about it. Um, Definitely, well completion, it is the final stage of any drilled well. When we drill a well and we turn it over to the completion, once you run the completion, then you are ready to produce from this well. And the philosophy of the well intervention is to maximize profitability without compromising, of course, with the safety and the environment. Uh, why I say is to maximize the profitability because when you design the completion, you need to be sure that you are trying your best to get every single drop of hydrocarbons from deep in the reservoir all the way to the surface. These hydrocarbons, while traveling from the reservoir, which might be 10,000, 15,000, 20,000 feet away, deep in, while traveling all the way to the surface, it ride a bus. The bus is the gas. The gas is the driving mechanism to drive these liquids all the way to the surface. So you have to be sure that the gas, which is deep in the well, while traveling all the way to the surface, he is not traveling alone. He is carrying in his hands the oil that we need. If the gas comes out alone, you are a loser. It ends up that you have maybe 70 or 80% of the reservoir still has oil, but you cannot get it. You need to go to what we call secondary recovery, or even sometimes secondary recovery doesn't work. We go to what we call tertiary recovery. Before I continue, I understand that during the course, you might have questions. Uh, while teaching, I concentrate on what I'm saying. And so I'm not looking at your chats. So I will leave. So please, any question, leave it in that box, chat. And at the end of the session, I will look at all this question and answer it one by one. So please keep this in your mind. Keep it, and I will look at it at the end of the session. Uh, it is not the way I like, but this is the online strategy. يعني I always like to teach face to face, but we cannot do this because you are in different parts of the world. I cannot be everywhere at the same time unless I'm a magician. يعني. So back here to the completion, we need this smart idea of being able to get every drop of liquid of hydrocarbon all the way to the surface. So let us take an example to explain this. Let us assume that we have a gas well. So let us drill this gas well. Now we need to run completion. What size of completion we will run? If you are familiar with the completion sizes, you might notice that we have wells, which is 3.5 inch to a certain depth. Then it is 2.78. Then it is 2.38. Some other completion are 3.5 from A to Z. Some other completion are 2.78 from A to Z. Some other completion are 4.5 inch. So based on what? What is the philosophy of selecting a certain diameter or selecting different diameter at certain depths? To understand this, I will give you this example of a gas well that we drilled. Once we drilled it, we decide to run 4.5 inch completion. So let us assume that this is a 4 inch completion. We run it in the hole. After running the completion, we are ready to produce from this well. Let us produce from this well now. We are producing gas, right? The gas, any gas well, when you are producing from a gas, the gas does not come alone. It comes with two liquids with it. Do you know the two liquids that come with the gas? I'll give you 30 seconds to think of, to tell me what are the two liquids that normally comes with the gas all the way to the surface. Water and oil. I will give you water and oil. Okay, any other answers? By the way, water and oil is not bad, but it is not, you are engineers, so you have to be precise in your wording. You should say water and condensate. It is true that condensate is oil, yes, but condensate is a very, very pure oil. You can drink it. It is pure. No, but you are right, water and oil. Let us say it is water and condensate, right? So el gas, while traveling, it takes in right hand the condensate, and in his hand, left hand, the water, and is traveling all the way to the surface. الgas, to be able to do that, he has to have enough velocity to do it. If الgas doesn't have this velocity, so in the middle of the way, he will close his eyes, open his hands to get rid of this heavy lift he has to be able to travel alone all the way to the surface. So it is true that at the end, you are getting pure gas. But this water and condensate that you lifted, it start to accumulate hydrostatic head till it reach that hydrostatic head is greater than the formation pressure, the well is dead. When the well is dead, you say, no problem. Let us get a coiled tubing unit, run the coil, run a coil, and then inject nitrogen. So nitrogen comes out of the coil tubing, lift the liquid all the way to the surface to reduce the hydrostatic head to reach a hydrostatic head less than the formation pressure. The well is producing again. Come on. This solution you just did is a temporary one because the same story would happen again, right? Okay, I'm just listening. The same story will happen again. Water and condensate will be dropped, creating hydrostatic head to kill the well. So every a couple of months or 3 months, you have to do the same job. So it is better to admit that you make a mistake. Your design is bad. And instead of running 4.5-inch completion on that particular well, you should run 3.5-inch. By running 3.5-inch, you reduce the diameter, reducing the area. By doing that, you increase the velocity. The relation between the diameter and the velocity is when you increase the diameter, you reduce the velocity. And vice versa. When you decrease the diameter, you increase the velocity. So by reducing the diameter from 4.5 to 3.5, you increased the velocity so the gas can carry out this liquid all the way to the surface. To do that, actually, you have to kill the well, bring a workover rig, pull the completion, buy a new completion 3.5-inch, run it back, and which is a process that will cost you time and money. We have alternatives of this. Maybe it is not the course to talk about it, but we have other alternatives that this is the 4.5-inch completion. So we can bring cold tubing, which is maybe 2/7/8 like this one, 2/7/8, for example, and we run this 2/7/8 inside the 4.5-inch completion. And now we can produce from the small completion we created, which is the cold tubing, but 2/7/8. So now you are producing from the 2/7/8. How to do that? Yes, we run the cold tubing without going into details. We run the cold tubing to a certain depth, then we cut the cold tubing from the surface and we hang it with what we call cold tubing hanger. Now your cold tubing, which is 2/7/8, is your completion string. And you produce from the 2/7/8 now. We call and this completion, we call it monobore completion because it's a monobore. Mono means single because it doesn't have any accessories. It doesn't have landing nipples. It doesn't have SSD, SPM. But we still need to have these accessories. But yes, we have special accessories for this particular new completion we created, but it is not the course to talk about it. If we have time later on, maybe we can discuss it here. But the aim of this example is to tell you that one of the factors selecting the diameter of the completion we run is the velocity we need to get this money, which is the hydrocarbons, all the way to the surface, free of charge, without paying money by secondary recovery or even tertiary recovery. What is the function of completion? All these are functional of compression. The main function of the compression is to produce hydrocarbon to surface or the river injection fluid to formation. Sometimes we need to treat this formation with a special fluid, special treatment like acids or something. Then we do this through completion. These main function requirements must be built into the conceptual design and include protecting the production casing from formation pressure. That's why we have Parker. Parker is to isolate this upper part of casing from the hydrocarbons or from the treating fluid we are running through the completion. We are protecting our casing. Protecting the casing from corrosion attack by well fluids. Well fluid is corrosive, definitely. Preventing the hydrocarbon escape to surface. We need a certain route for the hydrocarbons. First day, we discussed the barrier envelope, that we need the hydrocarbons from being in the reservoir, entering my well, all the way till it comes out in a certain route. That's why we create this barrier envelope, so it will not make shortcuts. Producing single or multiple zone, perforating, simulation azidizing or fracturing. We do this through completion. Completion type, we mainly have three types of well. We have a well that we produce from. We have a well that we inject into, like water injection. Or a well, we use it to kill. We have kill wells. We sometimes drill a well to kill a well. And what you see in front of you are different type of completion. We have what we call open hole. We have slotted liner. We have gravel bag. We have cemented, cased, and perforated. The difference between these, if we talk about the open hole one, if you look at this gray area, which is the pay zone, the pay zone is where our reservoir is. There is no tubing in front of it. So you are producing from the whole area. While the slotted liner we do it especially for sandstone formation, where when we produce from what comes out with the hydrocarbon is sand. This sand, when it comes with this high velocity, it hits the tubing, and when it enters the production tubing, it eats it, it erodes it with the surface pipe system as well. So to minimize this erosion and try to extend the life of this tubing we put this slotted liner. What is a slotted liner? It's a pipe like that, but it has a lot of slots all around there. So when the hydrocarbons comes out of the reservoir, it hits this slotted liner. When the sand hits the pipe, the sand falls down. And what goes into these slots is the hydrocarbons. So it's a kind of filtration. The same concept is the gravel bag. The gravel bag is where we put small stones. We take this from the nature, actually, water wells. So these small stones, we put it in top of the perforation, in front of the perforation, sorry. And then when hydrocarbons came out into my well, it hits this stone. So in sand fall down, and what goes between the grains, these tiny roads between the grains, is the hydrocarbon. So a gravel bag and the slotted liner is a kind of filtration system we use to filter this sand, not to erode my pipe while traveling all the way to the surface. And we have The last one, what we call cemented, cased, and perforated, is where we even have production. We have a tubing, we have a casing. This casing go through the perforating the pay zone, and then we perforate. So hydrocarbons go these from these nodes entering my well. We might have a single production zone. What you see here is a different type of single production zone. The first one you see here is a single completion. Single completion, we have one zone, one producing zone, and one single completion we produce from. The second one, we call it single selective interval, where we had two formations, but one completion. In this example, we are producing from the lower zone. The following example, you are producing from the upper zone only, because if you notice on this production tubing at the end, we put a wireline plug and we open an SSD here, sliding side door. So we are producing from the upper zone through the SSD into the completion. Here, in this example, last example, we are producing from both zones. So no plug in the production tubing and the SSD is open. So we are producing from both zones at the same time. We use the same technique when we have multiple zones. This is the same technique. When we run a completion, we run it with a lot of accessories. These accessories are these colorful stuff you see it in this sketch. We put these devices into 5 groups based on the use of each one. Yani, for example, we have a device we have a group, we call it circulating device. In this circulating device group, we put everything we run into the completion for the purpose of circulation. Can you tell me, guys, in this group, circulation device group, which devices I can put under this group that we run in the completion to give us the ability to circulate or communicate between the tubing and the annulus? I'm waiting your answers if you have any answer. Exactly. People, some of you, I have a question. And what is the space between the coil tubing and the tubing? This question was related the 4.5-inch completion that I run, and we run 2.78. The clearance will be between the 2.78 and the 4.5. Maybe your choice is not 2.78, by the way. Maybe your choice will be 2.38 or 3.5. And the clearance will be between the two sizes, between 3.5, 4.5, or 2.78, 4.5. To answer people who answer my questions, one of you guys, Ali, said nipples. No, Ali, not nipples. And nipples is not to circulate or communicate. And nipples is to receive flow control devices. But yes, Emmy, it is the SSD, not the gas lift mandrel, as you mentioned, but it is the side pocket mandrel. Side pocket mandrel, we can put circulation device, gas lift device, differential kill device. We'll talk about that later on. But yes, it is the SSD and side pocket mandrel. And we have a group, we call it isolation device, where we put everything here that we use it to isolate. And then we put a group, we call it anti-erosion device. And then the last group, we call it other, where we put there everything else that we cannot classify it into one of these groups. So if we start from the beginning, anchoring device, anchoring means it is a device that it anchor flow to receive. It is to receive a flow control device, which I mentioned it a while ago. This is the landing nipple. Landing nipple, the main purpose of the landing nipple is to receive well control devices. And in any completion, you might notice that we will have more than one landing nipple. Maybe two, maybe five, maybe seven. I don't know. It depends on the design. But don't let what is written there, like here, top no-go nipple. So people understand when we say no-go, that means nothing will pass. So how, Ahmed, you put on the top of the completion a no-go nipple, so nothing will pass? No, the, the no-go means actually that anything will pass except her own device will not go. The shoulder in the landing nipple will stop the device. Will stop which device? Her own device, but everything can pass. It is based on sizes. So landing nipple is mainly to receive flow control devices. And one day I was in one of the lecture, and then I had this question to one of the guys, and the question was saying, "What is the main purpose of the landing nipple?" And he has to select one of four answers for a statement. He select a statement saying that to correlated depth. And definitely he took zero in his question. And then he started complaining that he has been working as a wireline for the past 15 years, and he is using a landing nipple to correlate his depths. My answer to him was, I totally believe you. I know that. I did it myself. But this is not the main purpose of it. She is doing that. I mean, the landing nipple is doing that. That means is doing the correlation of the depth. She is doing that as a favor to you. But this is not in her job description. If you read the job description of the landing nipple, you will not see that one of her activities is to correlate the depth. But you will see clearly in a capital letter bold, it is to withstand, it is to receive and flow control devices. The flow control devices is mainly the valves and the plugs. But yes, it is true that she is correlate. We use it to correlate the depth, but this is a subsidiary. This is a favor, not in her job yet. Circulating device, as I mentioned, we have SSD, sliding side door, sliding sleeve, and side pocket mineral. Well, isolation device, the word, when you hear the word isolation, all what should be in your mind is Packer. El Packer is to isolate. If you look at this sketch, this is the Packer at the bottom here. What is below this Packer? Anyone knows what's below this Packer? Can I get an answer, if you please? Can you help me answer in this question? What is below this Packer? What is this part below the Packer? What we call it? I receive one answer. Any more answers? I received two more answers. The first answer said low completion. The other answer is entry guide. The third answer is Molly shoe. No more answers. طيب الانتري جايد or الميلو shoe actually this last bottom part. You see it? The last bottom part here. This is we call it the entry guide or the middle shoe harder. But I'm talking about this one. Yes, it is low completion. I would call it bottom completion. Look, guys, the طبعا I'm يعني I have 26 participants, but three only answer the questions. But The rest are just listening, huh? Type. The Parker is the line. Anything above the Parker, we call it top completion, which is hanged by tubing hanger. This is the tubing hanger, you see it here. The tubing hanger hang the top completion all the way up to the Parker. So what is on top of the Parker? We call it top completion, which is hanged by the tubing hanger. What is below the Parker? We call it bottom completion or tailpipe, which is hanged by el Parker. But then in the exercise, I'll give you a question. What is the purpose of the Parker? And then you select an answer saying that it hangs the bottom completion. For this answer, I'll give you a big, big, big zero like that, because this is not the purpose of the Parker. It does this, yes, it does this as a favor for you, but this is not the main function of the Parker. The main function of the Parker is to isolate the upper part of the casing. This is the main purpose of it. We have some other devices which isolate also, like tubing seal assembly and the BBR. The BBR stands for Polish bore receptacle. By the way, yani, each piece or each equipment I'm talking about now, or I mention it now, we will talk about it a little bit later on. But let us finish all of them. Then we'll start talk about each one separately. The anti-erosion device, we have two devices. We have blast joint and we have a flow coupling. The blast joint, it is this blue color piece of pipe. You see it in front of the formation. What is the purpose? What it is? It is a pipe. It has the same idea of the tubing, but it has a bigger wall thickness. If this is a normal pipe, which is in front of the perforation, when you start producing from the well, this production with a lot of sand coming out, it erodes the outer surface of the tubing. After few months, this part of the tubing will have a lot of holes. So it's like a net now. What should you do now? Kill the well, bring a workover rig, pull the completion, change the damaged part, put a new one, run it back, which is a lot of waste of time, waste of money. So instead, from day one, when we run this blast joint, which has a wall thickness, heavy wall thickness. So it will withstand this hits. It will last longer. If the normal one will withstand 6-7 months, it might stand 5-6 years. And sometimes we do it, by the way, with the same thickness, but different material, like tungsten carbide or ceramic. This is the blast joint. So we have also a flow coupling. We'll talk about the flow coupling. The other pieces that we cannot classify into one of these groups, it is like a wireline entry guide, a perforated joint, a control line, and the tubing hanger. In our mission, we need to talk about each piece or each accessories of these just a little bit to have a general knowledge. But before we talk about it, we need to discuss something very important. When we, as a production people, receive a well from a drilling department, because once they drill the well, they hand it over to the production so they can run a completion and produce from this well. You, as a production man, or production engineer, production supervisor. When you see if this drilled well from a drilling engineer or drilling supervisor, first thing to do with this well is to give him a shower. I'm joking, of course, Yani, but what I'm saying is you have to clean the well. Why? Because when you receive this well from a drilling department, it is full of rubbish. Yani, if you are at the surface and this is your drill well, if you look like here, like this to see what's in the bottom, what you'll see in the bottom, debris, scale, grease, tie wraps, ring gaskets, O-rings, uh, just imagine all kind of rubbish. So if you produce with this rubbish there, you're going to destroy your reservoir, you're going to destroy your completion, you're going to damage your surface facilities. So first thing when you receive a well from the drilling department, with all my respect to the drilling team, of course, Yani, please clean your well carefully to get rid of all this rubbish that they gave you with this drilled well. If you didn't clean it well, this is what we might get at the end: reservoir damage, equipment malfunction, incorrect gauge reading, incorrect barrier test results. The completion is two parts. One part is below the surface, below surface. The other part is above ground. What is above ground is the wellhead and the Christmas tree. Uh, for several years, working in oil field industries, international well organizations, I was under the impression that both wellhead and Christmas tree has the same meaning. Yani, what is this? This is a wellhead or this is a Christmas tree. It's the same. Till I found out that I am wrong. When I got the correct knowledge, I came to know that a wellhead is the components of tubing hanger, tubing head, casing hangers, casing heads, where on top of that, we put the Christmas tree. The Christmas tree is the group of valves that control the well flow. The connection between the Christmas tree and the wellhead, we call it THF, tubing head flange. And this tubing head flange where we uh, adjust our contract to zero while running coiled tubing or wireline. It is true that sometimes we refer to the whole thing uh, as a wellhead, but engineering wise, the wellhead and Christmas tree are two different parts. The connection between them is the THF, tubing head flange. You guys, if you went to the locations or to you see Christmas tree or wellhead in reality, or maybe in your study, you might notice that there is a hole, or there is a hole around the wellhead of the Christmas tree. This hole, we call it cellar. Any idea what is the purpose of the cellar? Can any one of you tell me what is the purpose of the cellar, which is this hole around the wellhead? Waiting your answers. No answers yet. I received nothing so far. At least if you don't know, write me. I don't know. So I know that you are You are there. I'm not talking to the sky. I'm talking to people who are listening to me or try to communicate with me. Yes, don't know. Thank you very much. I have no idea. Great. To provide additional height between the rig floor and the wellhead, or for easy access to the valves. I like this answer. To contain the wellhead and spills. Ah, you destroy your answer. يعني, if you say to contain the wellhead, I would give you the $10. But and the spills, then I need $10 from you. You destroy your answer to provide additional height between the floor and the wellhead. Okay, to contain the wellhead and spout. Okay, let us go. What is the purpose of this cell? Let us forget about the cell. Let us assume that this is our ground level. Let us drill now. When we drill a well from here, so we're gonna start putting the wellheads, the wellhead, which is uh, a modules of different valves based on how many casing you have. And then on top of that, you will put the Christmas tree. So the height of the Christmas tree now is too high. To go there to try to open or close any valve, you need to have wings so you can fly to reach the Christmas tree over there. To solve this issue, this is our ground level. So we drill this hole. This is the hole we drilled. So we start now from the bottom of this hole we drilled. We start putting the wellheads. Then we start putting the Christmas tree. So now the Christmas tree is handy for me. So the main purpose of the cellar is to accommodate a wellhead height. So the Christmas tree is handy. And by the way, if I pass by a well and if the cellar is not full of sands, I can see the bottom of the cellar. From the depths of the cellar, I can tell you if this well is deep or shallow. Why? Because the depth of this cellar actually is between 3 feet and 15, based on how many casing you have. In a shallow well, you don't have so many casing. You might have surface casing only. So you have only one valve on top of it. But if you have a deep well, you will have surface casing, maybe intermediate casing, and then production casing. You will have more well heads. So to accommodate this height, you have to dig a deeper cellar. Anyhow, the depth of the cellar is related to the depth of the well, and the main purpose of the cellar actually is to accommodate the wellhead height. So a Christmas tree is handy. What you see in front of you now is a Christmas tree, of course. From the bottom to up, the very bottom valve, we call it lower master valve. The lower master valve is a manual valve, and it is not an optimum working valve. And I always say in my courses, if you see someone who's going to close the lower master valve, ask him to stop and tell him, please come, make your hands like that, and then you tell him, don't do that again. This is your Lamborghini or Lamborghini. Some people doesn't understand what Lamborghini is. I have to say it Lamborghini, which is a very fancy car, very expensive one. This one, it is always in your garage. When you go to work every day, you go to with your Hyundai 79 model. You take this Lamborghini during the weekends only. When you go and meet your girlfriend and have a tour, then you drop here at home, you go back home, put the Lamborghini in the garage. The following day, you are using Hyundai 79 because you can accommodate the maintenance and the cost, the running cost of the Hyundai, but you cannot accommodate the maintenance and running cost of the Lamborghini or Ferrari. So please notice this is, you know, I said that in my in the first course and in all my courses. I said two devices. Please put it in your left hand pocket and zip it. Don't touch it unless you are forced to. These two devices are downhole safety valve and the lower master valve. And in emergency, when everything is black in front of you and you have to open your pocket to use one of them, which one you take first is the lower master valve. Keep the downhole safety valve last. So please don't touch this unless you are forced to. Don't spoil it by using it frequently. Because if this one is damaged, you are in deep trouble. You don't have any barrier below, so you can fix it. But we normally use the one which is above, which is the upper master valve. The upper master valve is always pneumatic and hydraulic, and this is the working valve. This is normally the valve we use. And this is the only valve that works pneumatically or hydraulically, and that's why first day we said this is the one that cuts. It has the shearing capability. It has the shearing capability because it is not by hand. It has more power, which is the air or the hydraulic power. Then we have this cross where we go this direction, this direction, this direction. If you go this direction, you will see here what we call kill valve. We use it for killing operation. It is connected to the kill pump. Many Christmas tree doesn't have this. And instead of the kill valve, they put a blind flange. And if they need to kill the well, they kill it from the Christmas tree from the swab valve from top here. On the other side, we have a production well valve. Then we have here a choke, the choke which controls the flow of the well. No flow, half flow, three-quarter flow, full flow, whatever. And between this choke valve, the choke and the production wing valve or flowing valve, we have a valve here. We call it SSV. SSV stands for Surface Safety Valve. Surface Safety Valve. Some people in the field, they call it actuator. Fine. But if we disagree with, if we didn't understand each other, we should go to the origin. SSV, Surface Safety Valve. Then on the top, we have what we call here swab valve or crown valve. The swab valve has nothing to do with the production of the well. The swab valve is mainly there to be able to rig up and rig down well intervention equipment, which is fire line, coil tubing, or snubbing. And by the way, all pressure control equipment is designed to withstand pressure from a direction of flow. The Christmas tree valve is a unique. The Christmas tree valve is designed to withstand the pressure from both directions. So that's why, for example, the swab valve, while production, swab valve is closed. Now the swab valve, it is to withstand the pressure from below, the well pressure that hits before it goes to the production facility. But when we rig up a well intervention, whatever it is, wireline or coil tubing, and we need to test this equipment, we test it against a closed swab valve where we apply pressure from above. So the swab valve is designed to withstand pressure from below and above. The upper master valve is the same. The lower master valve is the same. On top of the swab valve, we have the three cap here and the gauge. Let us have a a wireline job on rigless operation, and this wireline need to rig up their equipment. So one of the wireline team should go there, go to this quick connection, be sure the gauge is zero, and then take out this connection, which is hand tight, to put the crossover, then start connecting the rest of his equipment. And let us see this scenario where this gentleman or lady, he went to top, and he found that this gauge, which is on the top here, is broken. So what he did, he closed the needle valve below. He took this damaged valve out. He grabbed a brand new gauge. He put it in, opened the valve, see that it works, and then he bleed off the pressure and disconnect the cap. If I am the supervisor in this location and I knew that he did that, I should fire him. Why? People ask me why. What mistakes he did? What what do you need him to do? Technically, he did exactly everything right. Yani, I would tell him to do the same steps he did to change this valve, this gauge. But what is the fatal mistake he did? He did that alone. He didn't inform us. Us means the team. Yani, if we are a crew of five and each one did what he think is the best for the job, we are not in oil field industry. We are in a circus. He should inform his team. Um, I have a company here in Egypt. It's a service company, and I'm the managing director of that company. So when I go outside the office, we have a group on the WhatsApp. So I send to my engineer on that group, gentlemen, I'm going to meet this customer uh, to try to sign the invoice that he kept it in his drawer for the last 2 months. And then I will go have lunch with my girlfriend in the restaurant. What is the benefits I got from this little message I sent? Although I am the managing director, huh? That I might receive a reply from one of the engineers. Mr. Ahmed, do not go meet that customer because I was sitting with him last night at the cafe and he signed the invoice already. So he saved me uh, this bad look when I meet the client that guys, you didn't meet with you didn't see each other or what? I signed the invoice yeah, last night already. And also one of the other team members in my group will say that Mr. Ahmed, do not go to the restaurant because your wife put a tracking system in your car and she is following you. So I saved my life, right? So it is very important that we work in a team and everyone should know what others are doing. That's why I have to fire him. The other thing I would like to mention here before we move from this slide that if it is wireline, yes, it is nice that you will remove this cap and then put your crossover. But if I am doing a coil tubing job, I will not remove this cap. No. In coil tubing, I have to remove this flange. So I have to take all these stud bolts and nuts out. So it ends up a flange. My crossover should be flange to flange. الcoil tubing API standards now, every single connection from the from the Christmas tree all the way to the sky has to be flange to flange. Uh, the reason for that, I believe, yani, الثread doesn't withstand the torque. And if the connection thread, as long as you are 90 degree on the ground, you have no problem. But in cold teaming, this is not, doesn't happen. You always do like that. All what you need for the disaster is 1 degree of 90. This 1 degree of 90 will give you a force if this is your connection below, and then you have several risers and you have the injector. The injector is 6 tons. So if it is off 90, so the weight create the force or the torque created at the connection below is the distance times the weight. The thread is not designed to withstand this torque. The flange is designed to withstand this torque. Time is running. I don't believe that I've been talking for an hour now. I have to close my eyes and dealing like I'm blind and I'm not reading this, so I escape these slides. When we talk about the wellhead, which we said it is modules, يعني when we start, if we have a surface casing, then what you're going to put a surface casing head, where inside this surface casing head, you will put a surface casing hanger. This surface casing hanger, which is the brown color you see here, which hangs the yellow stuff here, which is the surface casing. If you intend to run after that production casing, then you have to put on top production casing hanger, where inside it you will put production casing hanger, which hang the green color production casing. If you are running completion, then on top of that, you have to put production head, tubing head, where inside it, you're going to put tubing hanger. This is the tubing hanger which hang the production tubing. And this is what we call tubing head flange, where you're going to put on top of it a Christmas tree. A tubing hanger, from its name, it is to hang the production tubing. And to be more precise, it is to hang the top completion only, because the bottom completion, we said it is hanged by the packer. And also, it has a profile inside it to put what we call BPV, back pressure valve. A back pressure valve, we use it as a barrier. Sometimes we need to put it in order to change the Christmas tree if the Christmas tree is damaged or leaking. Maybe this is the last thing to talk about before we end up our session today, is based on what we select our production tubing. When we go to the supermarket to buy a production tubing, we have to decide which type we buy. Our selection is based on so many things, actually. These things are the production rate, the well depth, the use of your wireline tools, how you pass, based on the pressure that can withstand, and the temperature which can withstand high temperature, low temperature, high pressure, low pressure. It depends on the grade. That's why you select the grade of the material you are using. On the tension you're going to apply to the burst limit of this tubing, the collapse resistance of this tubing, the compression that can withstand, the coupling that you are using, the corrosion, can it withstand the corrosion? That's why, for example, some completion, we call it 9 chrome. 9 chrome means what? It has 9% chrome. Some other completion are 13 chrome or 25 chrome. 25 means 25% chrome. Why chrome? Because the chrome is to withstand the H2S and CO2. So stimulation loads on that tubing, and erosion. So all these factors govern the way we're going to select which production tubing we are looking for. Uh, for example, يعني let us run completion to 15,000 feet. What hold the weight of the 15,000 feet of production tubing? At the surface, it is the tubing hunger. The tubing hunger is what holds the weight of the 15,000. Please go below tubing hunger. This part of the pipe, this part of the production tubing is hang 14,999 of tubing weight. If it cannot withstand, the pipe will split. And this is what we call the tensile strength of the pipe or the material. What is the tensile strength? The tensile strength, in a very simple way, it is the ability of the pipe to withstand its weight. Otherwise, it will be elongated and split. Oh, 1 hour passed quickly. I will stop here for today, and we'll continue Tuesday, 6:30. But before I leave, I need to see if you have any questions that I can answer. I have 2 questions so far, where we can get the PDF of the lecture, and is lecture upload in YouTube? So I understand, yes, but the one to answer this question is Dr. Ahmed Al-Garhi, who I believe he will answer you this question. I'm not the party who handled this issue. يعني.
Sure, all the lectures uploaded to PioPetro YouTube channel, so that you can find the recording maximum by tomorrow on YouTube. PioPetro
Okay.
YouTube channel.
I have another question from Horea. Hello, how can we remove the problem if it is found in the well through the Christmas tree? Your question, Horea, is not clear. What it depends on what problem you have in the well. Yani, uh, do you know how many issues you might have downhole? Each one of them has a certain way to solve, but you have to be precise which problem you have. Uh, but through Christmas tree fishing operation, fishing operation, for example, if you lost tools in the hole, this is the problem. How you solve it through the Christmas tree is you bring well intervention, coil tubing, for example, or E-line sometimes, or braided line sometimes, and rig up on the Christmas tree, and then run in the hole to fish these tools that you have downhole, and you pull it out. Sometimes we bring snubbing units that if the coil tubing are not able. So this is one of the problems. This is what you talk about, or something else in your mind. Emmy, does the use of flange-to-flange connection relates to wireline pressure control equipment? No, Amy, this is for coil tubing only. Up till today, wireline is allowed to use the thread connection, which is Acme threads. I believe because there is no weight. The Christmas tree doesn't have weight, but the coil tubing does have. What are the remedies if the Parker do not isolate the lower completion? El Parker does not isolate the lower completion. El Parker is to isolate the upper part of the casing. This is the main purpose of the Parker. If the Parker is leaking and it doesn't do this function, what you have to do is to pull the completion, replace the Parker, put new one, and run back. This is the all question I have, Dr. Ahmed. So
Yes.
please advise me if I should leave or you need me anymore.
Thank you very much and have a wonderful day. When we will see you again? When is the next lecture?
Tuesday, 6:30.
Okay, so we will see you Tuesday, 6:30. Thank you very much.
Okay, Dr. Ahmed. Thank you very much.
Thank you.
Thank you, guys. See you Tuesday, inshallah.